Remember that two lines on a coordinate plane that are parallel have the same slope. Now we know geometrically that two lines that are parallel run next to each other, they never intersect. Algebraically, though, when we talk about parallel lines, we really care about the slope. So this particular picture shows you one of the lines is the equation y equals 3x plus 8, and the other one is y equals 3x minus 4. Notice that the slopes are the same, but the y-intercepts are different. Two lines are perpendicular when their slopes are opposite reciprocals. Remember, opposite means you change the sign, so one's going to be positive, one's going to be negative. Reciprocal means you flip the fraction. Geometrically, we understand that perpendicular lines create a right angle. Two lines are said to be coinciding if they're the exact same line. So I want you to notice these two equations, x plus 3y equals 5 and 2x plus 6y equals 10, result in the same line on the coordinate plane. We call those coinciding because they're two different equations, but they make the same line. I claim to you that you can determine, without graphing, if two lines are going to be parallel, perpendicular, or coinciding. In order to do that, you need to put the equations in slope-intercept form. So, x plus 3y equals 5, I would subtract the x, and notice how I wrote the equation. I didn't write it as 5 minus x, I wrote it as negative x plus 5, and then I would divide everything by 3. I would get negative 1/3 x plus 5/3. Now let me work on the other equation, 2x plus 6y equals 10. I would subtract the 2x, and then I would divide everything by 6. Well, what ends up happening when you divide everything by 6 is you need to reduce those fractions. What is negative 2 over 6 reduced to? Well, negative 1/3. And what is 10 over 6 reduced to? 5/3. And that's why they're the same line, because they really are the same equation. When you have two equations, they do not necessarily have to be parallel, perpendicular, or coinciding. It is possible that they're none of the above. So don't assume that you're always going to have parallel, perpendicular, or coinciding lines. It could be none of them. One of the things we learned to do in algebra and geometry and algebra 2 was to write an equation of a line if we know a line and we want to find the equation that's either parallel or perpendicular to it. But you need to know a point on the line. So we want to find the slope-intercept form of the equation of the line that passes through the point to negative 1 and is parallel to 2x minus 3y equals 5 and is also perpendicular to that line. In order to do that, the first thing you got to do is you have to put this equation in slope-intercept form. In order to do that, the first thing I'm going to do is I'm going to subtract the 2x, and then I'm going to divide everything by negative 3. So y is equal to positive 2/3 x minus 5/3. I put it in slope-intercept form, so now I know the slope is 2/3. So in order to find the equation of the line that's parallel to it, two lines are parallel if their slopes are the same. So the first thing I want to do is I want to write an equation of a line that has a slope of 2/3 and passes through the point 2, negative 1. So I am going to use point slope form because that's my particularly favorite way of doing this. Point slope form was y minus y1 is equal to mx minus x1. This is not the only way of doing it. You may have had a previous teacher show you another way of doing it. You can also use the textbook to look at how they do it, although they use slope or point slope form. So the point gets plugged in for x1, y1, and the slope obviously gets plugged in for f. So y minus negative 1 is equal to 2/3 x minus 2. In order to put that in slope-intercept form, this becomes y plus 1, and I'm going to distribute the 2/3 on the right-hand side. I get 2/3 x minus 4/3. And then I'm going to have to subtract 1. If you feel uncomfortable with adding and subtracting fractions, remember you can just do this on your calculator. However, I am going to insist that your answers are in fractional form and not as a rounded off decimal. If you do negative 4/3 minus 1 in your calculator, you should get negative 7/3. I'll show you the way to do this by hand. The way we do it by hand is we change 1 into 3/3 because 3/3 is an equivalent fraction of 1. And then it's a subtraction problem, so you're really just doing negative 4 minus 3 in the numerator. And the denominator stays the same when you're adding or subtracting fractions. So this is the equation of the line that's parallel to 2x minus 3y equals 5. What if I want to go back now and do the equation of a line that's perpendicular? Well, the slope this time is going to be the opposite reciprocal. So it's going to be negative 3/2. And it's still going to pass through to negative 1. I'm still going to use point slope form. So y minus negative 1 is equal to, this time for the slope, I'm going to plug in negative 3/2, x minus 2. I'm going to change this to positive 1, and I'm going to distribute the negative 3/2. I get negative 3/2 x plus 6/2, which is 3. Oh, isn't that nice? So I'm going to go change that, because now when I subtract 1, it's much easier. And the equation of the line that's perpendicular to the original line is going to be negative 3/2 x plus 2. In this next problem, I'm going to incorporate some geometry into the algebra so you can see a connection. I'd like to determine the equation of the perpendicular bisector of the line segment with endpoints A at 2, 3 and B at 6, negative 1. In other words, if I have a coordinate plane and I put a dot at 2, 3, and I put a dot at 6, 3, 4, 5, 6, negative 1, and I draw some line through it, I want to, let me do this, because it said line segment. What's a line segment? It is a line with 2 definite endpoints. All right, so to find the perpendicular bisector, perpendicular means I need the slope of the line perpendicular to AB. A bisector, remember a bisector is a line that cuts the segment directly in half such that both segments on either side are congruent and it's perpendicular. All right, so I have to do a couple things. Number 1, I got to find the slope of AB. How do you find the slope of AB? Well, the slope formula is y2 minus y1 over x2 minus x1. So, negative 1 minus 3 over 6 minus 2. So that's negative 4 over 4, which is negative 1. Yeah, that's a nice slope. That's easy. So, if that's the slope of AB, the slope of the line perpendicular to it is also negative 1. Not negative 1, it's positive 1. Perpendicular bisector. Perpendicular, opposite, reciprocal. So opposite means change the sign. So if the original slope was negative 1, the new slope is going to be positive 1. Reciprocal, flip the fraction. Well, what's the reciprocal of 1? It's 1. All right, so I know the slope. But in order to find the equation of the line, you got to know a point on the line. Well, here's the thing. They told me that it's a bisector. And if a bisector cuts this in half, then where is that point directly in between A and B? It's the midpoint. And the midpoint had a formula. To find the midpoint of any line segment, it was x1 plus x2 over 2 and y1 plus y2 over 2. The midpoint is an ordered pair. And to find the ordered pair, you basically find the average of the x coordinates and the average of the y coordinates. Okay, so to find the midpoint, I'm going to do, let's see, the x values were 2 and 6. Oops, sorry. 2 plus 6 over 2. And the y coordinates were 3 and negative 1. 3 plus negative 1 over 2. So I'm going to get 8 over 2 and 2 over 2. So the midpoint is at 4, 1. Well, I know the slope. I know a point on the line. I can now find the equation of that line. And the easiest way to do it is to use point-slope form. So y minus 1 is equal to 1 x minus 4. When you distribute the 1, you just get x minus 4. And then you add the 1 and you get x minus 3. This is the slope-intercept equation of that line. And that is the important information from section 1.5 on writing equations of parallel and perpendicular lines.